Okay, so as we look at this bell work, the basic idea is that the standard deviation changes from 3.6 to 3.5. Everything else stays the same. We don't know what the z-score was to begin with, and that doesn't matter. And honestly, the mean here doesn't matter, because the only thing that we're worried about is the fact that we're going from 3.6 in our original calculation to 3.5. So it's really more of an algebra question, though with a little bit of statistical concepts associated with it. So remember, if I reduce my divisor, then what that does is it increases the quotient. So what I mean by that is if I divide by a smaller number, and here I went from 3.6 to 3.5, my z should be getting a little bit bigger. And if my z-score gets a little bit bigger, that means it is further from the mean. I don't know what the z-score was originally. It could have been negative. So if it was negative, it's going to be more negative now. If it was positive, it's going to be more positive. Or that doesn't make sense, but I think you get the idea. It's going to be further from the mean, spread out further. So a little bit of confusion here is this, that it will increase in value. And that is, I understand why you might have picked that one, but and maybe it's some phrasing on my part, but yeah, you want to answer D. And just hopefully that makes sense now. And one thing that I did want to say in general is that the AP test tends to do a good job with their wording to make sure there's no trickery going on and confusion. And sometimes whenever I write something, it's not as clear exactly what was meant. I try and be as clear as I can, but I can make mistakes. So anyways, let's look at what we're doing today. And at this point, if you're a TA, I see that you were logged on and you can enjoy the rest of your day.
Thank you, Mr. Davis.
All right, have a good one.
Yeah, baby.
50.
Okay, so today we're looking at normal CDF and inverse NORA. I will say, based on how my last class went, we're really gonna be looking at normal CDF and a little bit of inverse norm. So tomorrow we're gonna pick up here and try and get more review of this. This is the big takeaway from the chapter, understanding these two calculator functions and how they work. Okay, so we'll go ahead and get started. We're just gonna do a lot of practice problems, a little bit of concepts, but a lot of practice problems. So the name normal CDF, what does that even mean? Well, normal means that it's related to the normal distribution. And if you look in a minute, whenever we find the normal CDF in our calculator, if you scroll down, you're gonna see there's lots of different CDF. There's what's called T-CDF, binomial CDF, geometric CDF, all kinds of different, well, CDF is a cumulative density function. Basically, it means the area underneath the curve. And we're gonna go into that in more detail, but the density is, you can think of that as the area under the curve. Okay, so we're looking at the area under the curve for a normal distribution. And you will see the very first option is normal PDF, which is never used. So don't worry about that. And this is something, I'm going to come back to it. Right now, it might be a little bit of an odd thing to say, but percentiles are measured from the bottom up. So from the lowest up to the top. So when you see 75th percentile, it's how many are measured underneath you. And that'll be important as we do this. Okay, so you've got your calculator. You could have different menus based on if you have like the TI Nspire.
Hey, Mr.
Okay.
Davis.
Yeah.
I'm here. I was told that you marked me absent,
Okay.
but my iPad was disconnected for a second.
Don't worry, I've got you. I thought I saw you check in.
Sorry
Thanks for
about
letting me know. Okay, so as far as what you will need for this class, the calculator, if you have not gotten a calculator from the library, you can get this kind of TI-84 at the library. A lot of you already have it and have been using it, but if you don't have it yet, that's an option. The instructions that I give are going to be for TIs, and I will tell a little bit about what to do for TI Nspires, even though I don't have one. If you have a Casio calculator, like one of the ClassWiz, I can give you some information on how to accomplish the same tasks, though I don't know it personally. Okay, so some of the stuff I'm explaining today, you might need to learn those functions separately. Okay, anyways, I will say just right off the bat, if you do have a Casio, you should be able to find a lot of this from, if you hit, I think it's the menu button at the top of your calculator, and then you have a few options. One of them is for distributions, and a lot of those same kind of calculations will be found there, though I can't give you all the keystrokes. Okay, so normal CDF is what we're going to be working with starting today. And you have some options. You can set a lower option. This sets the lower bound of the area you're interested in. Upper sets the upper bound of that area. The mean and the standard deviation are exactly what you think they are. If there is no upper or lower bound in the problem you're working on, set them at positive or negative 99999, just something really big. It doesn't have to be that exact number. You can see right here in this example, you go even higher. We will talk about all this. So right now it might not make tons of sense. Let me go back to that real quick. I'm not sure if there's anything else that needed to be said. But yeah, we will, for the mean and standard deviation, you can change it. You can see that right here. But we're going to always use a mean of 0 and a standard deviation of 1. So my expectation is that you never adjust those numbers. It can be done. And in the real world, if you're doing stuff like this, you might change those numbers, but not in this class. We're going to standardize our scores every time. So when we standardize our scores and turn it into a z-score, then that means we're always working with a distribution with a mean of 0 and a standard deviation of 1. And the reason we do this is later in the course, we're going to have to show our work. And the best way of doing this is to show the calculated z-scores. And if we don't have that to show, we really don't have anything to show. All we could say is, I plugged it into my calculator and got an answer, which isn't good enough. All right. So showing your z-scores is a good way of doing this. Okay. So I'm going to just bring all this up and then we'll talk through it. So what exactly is your calculator doing when you run a normal CDF? Okay. So you have a normal curve, and this is assuming a normal curve. You're giving it a mean and a standard deviation, which is always 0 and 1. You can see that's what we have in this example. When you set the lower and upper bounds, what you're doing is you're saying, I want to find the area under the curve that falls between those bounds. So let's say you only want to find the area under, this particular z-score. So what it's going to do is it's going to say, here's my upper bound is whatever that is. That's about 1.4 or something. And my lower bound, I don't have a lower bound, but I need to set it. So I'm going to make it like negative 99999, which is just unbelievably low. So that's good enough. So what it's going to do is a calculator is going to use its pre-programmed calculus in there, and it's going to find the area of this. So when I was saying yesterday that this area is, we can calculate it through calculus, the calculator is doing that for us. We're not doing calculus, we're doing calculator. Okay, so now it's going to give us an area. Now, to that end, it should be pointed out that if I didn't have anything here, the area under the curve total is 1. So if I only have a portion of that, it's going to be some fraction of 1, right? So let's say this is 0.9. 90% of the data is right there. So this is giving me also, and this is what the last thing is talking about, it's essentially a probability. So if I picked a random case, what is the probability that it's going to be in that clump of data? Well, there's a 90% chance. It could be in this clump if I just grabbed a random one. But most of the data falls right in that data on the left. So when I say 0.9 is the area, 0.9 is also the probability. So conceptually, is that making sense? Oh. Person joining us. Okay. So if that is making sense. We're going to draw pictures as we go through. Oh, I need to end the poll and close it all down. Sorry, that poll was still up. Okay, let's start going through some problems. And I'm going to run through these for everyone at the beginning. And then at a certain point, I'm going to kind of turn it over and have you guys start putting the answers on the screen, okay? But let's see what we got here. In a certain warehouse, times that orders are filled are approximately normally distributed with a mean of 48 seconds and a standard deviation of 6 seconds. How many orders will be filled in no more than 54 seconds? Okay, so I've got my normal curve. I didn't need to trace it. I'll just get rid of that. There's the normal curve. If I didn't have it, I'd want to kind of draw this to make sense of it. So my mean is 48 seconds. And then since it's a standard deviation of 6, I've got 42 down here, 36. I'll only go 2 out. That's 54 and that's 60. Okay, so how many orders will be filled in no more than 54 seconds? So anything that takes less than 54 seconds is fine. Up to 54 seconds is fine, but no more than that. So I will put that right there, and I can see that 54 seconds happens to be my first standard deviation. But what I want to get into the habit of doing is calculating the z-score. Now, in this case, I'll tell you the z-score is 1, but we can confirm that because my data point is 54. The mean is 48. So if you're ever not sure which one is your x, well, it's most likely going to be the value that's not your mean, okay? So 54 is a data point I'm interested in. The mean is 48. How unusual is 48? Well, it is 1 standard deviation above the mean. And I made this first example one that's pretty straightforward. So now I want to plug this stuff into my calculator. And I want to figure out what this area is that I have marked below 54, below 1 standard deviation. So because I converted it into a z-score, the first thing I want you guys to do is hit second and variable. So you go to your distribution menu, pull up your normal CDF. My lower bound right now, if you first open this up, you're probably going to see -1E99, which is basically like negative Google. That is incredibly low. If you don't have anything there, you can just put -99999. So that's our lower bound. It's actually not going to infinity, but it's going really far. Our upper bound we're interested in is that 1 standard deviation. So my upper bound will be 1. I keep my mean and standard deviation at 0 and 1. I paste it. Now when I do this, it is just going to give me a function on my main screen. I have to hit enter again, and it's going to give me a number. The actual number you should be seeing is 0.8413 ... And this is something we could have gotten just from our 68, 95, 97, the empirical rule. Because we know, I won't go into too much detail on this, but 1 standard deviation, this is 68% of the data, which means the other 32% of the data is going to be 16% right here and 16% right here. I don't know where I wrote 19. So basically it's going to be all of this data, which is about 84%, and the 16% up top is not included. So that's why it's 84%. Of course, this is kind of a simple example, and we're going to be jumping into all kinds of different problems we could be facing. But is everyone good with this so far? And you can chat questions, chip in if you do have questions along the way. So now the only difference between this one is that our standard deviation has changed to 5. And I'll tell you for the next few questions, I don't know how many, it's going to stay with the same mean and standard deviation. It's just the question about it that changes. So how many orders will be filled in no more than 54 seconds? That's the same question we just did. But my situation has changed. now, let's see, 48, so that's going to be 43, 38, this is 53, 58. There it is. So 54 seconds is going to be somewhere about right here. It's bigger than 1 standard deviation away. And I want to find all the orders that are no more than 54 seconds. So I want to calculate z-score. So 54, right there, minus the mean, which is 48, found in the problem, divided by the standard deviation of 5. And that, I can get an answer. 6 divided by 5 reduces down to 1.2. All right, now sometimes it's a really weird, it doesn't want to write. Okay, 1.2. Sometimes you get a really weird z-score, but now when I plug this in my calculator, same as before, but instead of my upper bound being at 1, it's going to be at 1.2. So just that 2/10 of a z-score difference means that my this area underneath goes from 84% to 88.5%. You should see the numbers 8849 ... So when you guys start writing the answers on the screen, you can just put the first 4 decimals and call it good. Round also. So anyways, 8849, 88.5% of data will be less than 54 seconds. That's good. Okay. So let's look at another problem. And I'm giving you all these different types of problems so you can see all the different types of analysis you might need to do. In a certain warehouse, I'm not going to read all of it, it's the same thing. A mean of 48 seconds, standard deviation of 5 seconds. The CEO says that if you take more than 1 minute to fill an order, you will have a mark against you in your file. How likely is it that this will happen on any given order? Okay, so we need to kind of conceptually figure out what this is asking before we can just start plugging numbers in. Okay, so I know z-score is going to be involved, so let me just start off with this. I've got 48 is the mean and 5, but I need to figure out some other stuff. So if I take more than 1 minute, so I know 1 minute is going to be the data point of interest. That's 60 seconds, so I'll calculate that in a second. You can calculate that now, but we want to figure out how likely is it that an order is going to take 1 minute or longer to fill. So the z-score right here, if we calculate that, that's going to be 12 divided by 5 is 2.4. I can't write right on the edge. Whatever, 2.4. And so I'm looking at a data point about right here, a little bit further to the right than what I drew. But 2.4 is the z-score. And I'm interested in what is the probability that the data falls in this little sliver of the curve. All right, so conceptually, hopefully you're following along with that. And anyways, now if we were drawing a picture and we wanted to show our thinking, we might not label this with our 0, 1, with our z-scores. We might label this with 48, 53, 58, and of course this would be at 60, and that would be 63 right here. So if I go to normal CDF, now what I have is a lower bound of 2.4, and my upper bound is what can get stretched toward infinities. Here's where I'd put a 99999, just stretching. And go ahead, once you've done that, you can plug this, or someone writes down the first 4 decimals on the screen of what you get. Okay, so what we should be seeing when rounded is a 0.0081. So if you got the 0.99 something, then what you might have done is done the 2.4 is your upper bound, and the negative 999 is your lower bound. So instead of getting this sliver of area right here, you're instead getting this area. All right, so those are the things you have to kind of be on the lookout for. So there you go. It is 0.0082 when rounded. And what that means is that there's less than a 1% chance that you're going to take longer than a minute. Okay. So let's look ahead. Now, the CEO, on the other hand, also gives bonuses to people who finish with an order in less than 40 seconds. And of course, these can cancel out the bad marks, so that's good. How likely is it that you are going to have that happen? So what I want you guys to do is, at this point, see if you can figure this out on your own and put on the screen what that area is, what the answer is.
Mr. Davis, I have a question.
Yeah, go for it.
When I was disconnected at here, like the first part of your lesson, when you're talking about the normal CDF, what do you plug in for the lower and upper in the calculator?
What you need to do is, it depends on the problem. Your lower and upper are going to be the bounds that we set. So that's a good question. I see the correct answer right here, so that's good. Let's just walk through how we get that, because there's probably more than one person a little confused on this. So 40 seconds, we want to find out how rare is that to finish an order in less than 40 seconds. So we have a mean and a standard deviation of 5. So what I'm going to first of all do, I just wrote the z-score formula here, but I want to fill in my mean and the standard deviation. And I want to have the data point of interest. So this 40 seconds right here. And we'll get to the upper and lower in a second, but first I need to find a z-score. So that's going to be negative 8 over 5, negative 1.6. Okay, so now we get to the upper and the lower. And we need to get that from the question itself. It says, the CEO gives bonuses to people who finish an order in less than 40 seconds. So knowing that my mean is 48, and here's 43, 38. Of course, I got these numbers up ahead, so 53. And anyways, 40 seconds is going to live about right here. And again, it's that negative 1.6 z-score. So less than that would be this side of that z-score. So I want to get this area under the curve. And that's what normal CDF will calculate for us. And knowing that this is kind of the area I'm looking for, that means that my upper bound, let's put UB right here, is going to be that. My lower bound is going to stretch toward infinity. So in that case, I just put negative 9,999, you know. That would be plenty sufficient. Because remember what we're saying with that negative 999 whatever is that that's negative 99999 standard deviations as our lower bound. That's incredibly low. Just whatever differences you get there by adding another 9 doesn't make any difference at all for us. So when we plug that in for normal CDF, if you haven't done it yet, that's where you get your about 5.5% chance of that happening.
And I think I saw this on one of the slides. You said we keep the mean and standard deviation at 0 and 1.
Yes.
So we don't change anything. Okay.
Exactly. Yeah. We're always converting to z-scores first. So that means that we're always going to be working off of a standardized normal model, which has a mean of 0 and a standard deviation of 1. Okay, all good questions. Let's look at another one. And I want to just ask, what do you think we need to do for this problem? You don't have to go through all like the calculations, but just conceptually, what do we need to do for this problem?
Can we calculate the standard deviation on each side of the mean and then add those total to get the percentage?
I think part of what you said is on the right track. I'm not sure if what I heard is exactly what we're going to do. So I'm going to label this real quick. Here's a 48, 53, 58, 43, 38. Hopefully those numbers are showing up clear enough. So 40 seconds is going to be about right here. 50 seconds is about right there. So what do we do?
Do we need to find both of the z-scores for 40 and 50 and then put them as the lower and the upper?
Perfect. That's it. So let's do exactly that. Good job, Matt. Okay, so we've got 40 is our data point of interest for the lower bound. And of course, you don't need me to do this calculation for you. I'll just set up the problems. In fact, all I'm going to do is set up these two, and you guys can tell me the final answer for this. But whatever z-scores you get, just like Matt said, those are going to be your your lower and upper bounds. And that will tell you this area. Ah, sorry, that was something happened there. And as soon as someone has an answer, you can write it down, but everyone, see if you can plug this in and come up with exactly the same thing. Okay, and the answer is on screen. We're getting another person putting it. That's good. Okay, so hopefully everyone is getting that. You don't, so that's great. Everyone's kind of confirming. They're all getting the same answer, 0.6006. And if you got that, that is good. And again, to interpret that, what we're saying is that 60.6% of all of the shipping times are going to be between 40 and 50 seconds. And another way of thinking about that is, like we said, is probability. If you were to pick a random shipping time, there's a 60% chance it would be somewhere in that range. Okay. I think it's good to have that understanding about it right now. So it looks like you guys are doing pretty well with this. Now, this is one where the phrasing here confused some people in 5th hour, and I understand why. So a bonus is given every month for every worker in the top 20% for fastest average shipping time. And before we move on, what qualifies as a good percentile if we were using that normal distribution from before? Like, would you want to be in the 5th percentile or the 95th percentile in this case?
The 95th, right?
Well, again, this is where the phrasing is a little bit weird. Normally being in the 95th percentile is good. And maybe what I because our distribution is set up with the faster times at the low end, so theoretically it goes from 0 all the way up to infinity, but the faster you are, the lower you are. So in this case, maybe my phrasing was a little bad. What I should have said maybe is the bottom 20% for average shipping time and get rid of this fastest. So if you're in the bottom 20% for average shipping time, that means you're among the fastest. Does that make sense? Okay, so this is one where we don't need to do a lot of complex calculations or anything. This is more of a conceptual type question. So let's say the bottom 20% lives about right in this range. So those are the fastest average shipping times. So one of your coworkers is in the 13th percentile, which means 13% of data falls below him or her. One is at the first quartile. Well, what does first quartile mean? What percentile?
Wouldn't it be the
25, there it is. So this, I know we're mixing our IQR and other stuff, but we can still talk about this. That's still the 25th percentile. And now you have a z-score of negative 0.9. The z-score is already given here. You don't need to worry about mean and standard deviation because we have a z-score. So what do we do to find our percentile? Thoughts? Well, let me direct you just to your normal CDF. So, and I'll draw a distribution real quick. This will be a standard one. So here's 0. Here's the negative 1. Here's 1. If we're at negative 0.9 already, to find our percentile rank, we just want to get the area below that. So we now know what we need to do, right? We have our calculator, we can figure out what that is. And if you've been able to find what that is, as far as what the percentile is, go ahead and write that on the screen. Perfect. There it is. So we're setting our lower bound at negative 99999, our upper bound at negative 0.9. And not only does that tell me the area underneath it, but it's also telling me what percent, there it is, what percent of data is underneath that point. And so that's giving me my percentile. So I'm in the 18.4th percentile. All right, so in order from the fastest to slowest, who's fastest, A, B, or C?
A.
A is. So the lower your percentile in this case, the faster you are. So A is the fastest. Who's second fastest?
C.
C. And being in the 25th percentile means, in this case, you're actually the slowest, B. So who actually qualifies for the bonus?
A and C.
A and C do. Okay, it's a weird kind of conceptual question. Notice we didn't have to calculate a z-score. The first two were kind of already given to us, 13th and 25th. We just needed to figure out what it was for a z-score of negative 0.9. Okay, a few more questions, and we might just introduce inverse norm today, but we'll spend tomorrow focusing on that. All right, we'll jump ahead to this problem, and I actually want you guys to figure this one out without me saying anything. So take a few minutes and try and work through this one, and we will talk through it at the end in case you get stuck. While you guys are working, if you know exactly what you're doing, you might already be finishing up right now. Don't write anything on the screen just yet. What I'm going to do is I'm just going to draw our distribution for this problem. So if those are our commute times normally distributed, then maybe look at that and see if you can figure out what you need to do to answer this question. Okay, so let's kind of talk through it. Actually, real quick, if you were able to go through and get the answer, go ahead, just put the answer up on the screen. And we can check to see if it was right in the end. Okay, so we're hovering around 10%. A little bit above, a little bit below. We'll see why it might have worked out that way. So, but just to talk through it, what, assuming that showing up right at 8 o'clock is fine, how long, what is our X value that we're interested in for this one?
30.
30. So, and what are we worried about? So that's actually right in between right here. And what are we worried about right here? Are we worried about being to the right of that line or to the left of that line?
To the right.
To the right. Okay, we don't want to be in this area. We want to know the likelihood of being 30 minutes or longer. So, okay, now we know our standard deviation is, oh, I did my math wrong. That should be 34. Oops. I think I did it right on the other end. Okay. I was thinking some of this off here. Anyway, sorry. This is 30. So 30 minus 20 divided by 7. So that's 10 divided by 7, which is 1 point. And I'm going to let someone else fill in the rest of that decimal. Okay, so this is now our z-score. Thanks for filling that in, Zach. Okay, so now it's just as straightforward as plugging that into the calculator. My lower bound is 1.428. The upper bound is 99999. And when we do that, because we're seeing a couple of different answers that are all pretty close. So 1.428 up to 99999. I'm seeing about 0.076. Well, if I do the first four numbers, 0.0766. So something got a little bit off in some of these answers. 10% is in the ballpark, but the correct answer is there's about an 8% chance. Okay, and I do see that one right here, Jacob. So good job. So questions on any of this? I'm just going to pause. Any questions so far that you want to ask? And it doesn't have to be on this particular question.
We have to be given all three, like mean, standard deviation, and R like data to find the stuff, right? There's like no way we can find it out without all of them.
Yeah, there are different things that could happen. And let me see if, okay, this isn't the type, I'm actually going to go back. There could be questions set up that might say like, actually, I will say when we get to inverse norm, you'll see different types of questions that come up more frequently, where they give us certain information and we need to work backwards maybe to solve for the standard deviation, or work backwards to solve for the mean. But generally with normal CDF, you're starting off with the mean and standard deviation. Though, yeah, that is, yeah. Hopefully that's, I didn't answer 100% on that, but generally you'll have the mean and standard deviation and you can solve for the area from there. Okay. So I think once we have inverse norm introduced, you'll see kind of all the different ways you could be asked questions. So we're only seeing half of the story right now. Okay, a family, this is going to be one where you guys solve it, and I'm going to put a poll up. I'm going to give you guys as much time as you need and see if you can get this one solved. So over half of you got this one right. That's good. We'll talk through it. And some people got it wrong for reasons that I can imagine what's going on. So first of all, the answer was 12%. So a lot of you got that one right. And, you know, again, just visually to make sense of this, you want to get into the habit of kind of having a picture. The mean is 36,350. You have your first standard deviation away is going to be a little less than that, which should be, what is this, 35,207. And actually, I'm not going to worry about the other ones, because what we know is that the $35,000 budget of this family lives about right here, right? So there's 35,000, and that's their budget. And you don't break your budget, you don't go above it. So we're looking for this area below. So really it's as simple at this point as finding what that z-score is and setting our upper and lower bound, normal CDF. Okay, so I won't necessarily go through all of this, but 35,000 is the data of interest minus 36,350. And again, as long as you're kind of getting to this point, just keep in mind that this z-score, I think I remember it's something like 1.18. Is that right? You can write, someone can write it on the screen. There it is, 1.1. Okay, that's, so yeah, sorry, negative, thank you for adding that. So negative 1.18, so right there, negative 1.18, and you know, you might go further as far as decimals go, but for our purposes, talking about it right now, we want that to be our upper bound, and our lower bound is negative 99999, and that gives us that 12%. If you got 88%, which some people did, then you did everything the right way for z-scores, but you might have put that negative 1.18 as your lower bound and 99999 as your upper bound. So of course, that 12 and 88 would add up to 100%. So you found this area instead. The 15% could have come about if you put in the wrong z-score and you were close, but no one answered 33%. So that's kind of the oddball one. So anyways, hopefully that's good. With the last little bit of time, we don't have much. I just wanted to introduce inverse norm. I do not expect you guys to understand this, so we're going to go through a lot of information on this tomorrow and really try and solidify it. But inverse norm is the opposite. So if normal CDF allows us to find the area under the normal curve for a given z-score, then inverse norm basically does the opposite. It says, here's the area, what z-score gives us that. So if you wanted to find out what value is at the 25th percentile, well, 25% is your area. And then you can figure out what z-score that would equate to. Now, this is where some of you have a different, I'm going to just bring all this up real quick. Okay, some of you, when you bring this up, you go to distributions menu, it's option 3. If you have a TI Inspire or certain other calculators, it might give you tail, left, right, center. I will go into more detail about that tomorrow, but that, you want to generally leave that at left, and I will explain what the right and center are for. But once you understand the concept, then you can figure out how to set that left, right, and center. Okay, but we leave the mean and the standard deviation as 0 and 1, just like before. When we do this, it's going to give us the z-score. So I'm going to do one example, and we're going to call that the end of class today. Okay. And again, notice kind of the difference in the question here. If this was another question, if this is a normal CDF, it might say, Theo's salary is blah, blah, blah. What is the, how many, or what percent of salaries are higher than his? Then we could, of course, kind of proceed from there. But this says he's at the 75th percentile. What is his salary? Okay, I don't know. But I'm just going to remind you, first of all, we have the z-score, x minus the mean over standard deviation. So x is his salary, the mean is 42,500, and the standard deviation is 2,700. If I could figure out what the z-score was, then I'd be good to go. Well, I can do that. So what z-score corresponds with the 75th percentile? And I actually want you guys, I meant to do this before we started approaching this problem. Before we do this, I want you guys to just go to your inverse norm menu and just plug in 2 different numbers. It can be any numbers you want, but pick one of them below 50% and one above. So for area, if you want to do the same as me, I'll just start off with 0.186 or 185 is what I put in. So when I do 0.185 for inverse norm and I leave everything else the same, I get this. Okay. And we'll interpret this in a second. If I do inverse norm and I do something over 50%, I'll do 0.621. Then I have, this is my answer, 0.3081. All right, so negative, I already forgot what it was. But 0.12 whatever I plugged in gave me a negative number. This is the z-score that corresponds with giving me that area under the curve to the left of it. 0.3081 is the z-score that gives me that 0.621 area under the curve. So these are z-scores. All right. And it makes sense. The reason I wanted under 50% and over 50% because under 50% should give you a negative 1 and over 50% should give you a positive 1. Okay, so if that's good enough just for today to get that kind of basic level of understanding, let's just finish this problem. So the 75th percentile, what I want to do is inverse norm. My area in this case is 0.75 because that's 75% of values below to the left. And now it tells me that my z-score for this is 0.6744. That's right, 0.45 when you round. That won't make a big difference, but still. So now I can plug that in. 0.6745 is my z-score. And I can now do some algebra to solve for that. I'll do that really quickly. I'm not even going to show that, but I can multiply both sides by 2,700. Oops. All right. I'm not doing things with my calculator correctly. times 2,700. There we go. I can do that. So this is going to be 1,821.12 equals x minus 42,500. So if I add 42,500 to both sides, I get his salary is $44,321.12. And again, the last part's just algebra. Okay, we're going to end it there. And hopefully, just as an introduction to the inverse norm, you can see kind of the difference. We will spend tomorrow going through all kinds of different problems with this. The last thing I wanted to show you, and you'll see that I have to click through a lot of problems here. Information. There we go. This is where I wanted to get to. Your homework is right there. There's only one part you need to answer. If you feel like you understand inverse norm, you can try all the homework tonight. If you want to wait, we will go through this more tomorrow. We are going to also practice with shifting and rescaling data tomorrow, and just some conceptual things related to that. So go ahead and work on this whatever you can with normal CDF. And if you have questions, I'll stick around. Otherwise, you may go. Have a wonderful day.
Thank you, Mr. Davis.
Thank you.
Thank you, Mr. Davis.
All right, have a good one.
Have a nice day.
Thank you.
Yeah.